we are going to do a level order traversal for this binary search tree, which is same as the level order traversal of the binary tree. And we'll add some values inside the tree, use our insert function, and then do a pre-order, in order, and stuff like that. So this should be pretty easy. We'll actually say public void, and we'll say level order. So we are doing a level order traversal for this one. We'll first check if root is equal to null. If root is equal to null, we just return, because there's nothing to be done. Otherwise, we actually take a queue of node called queue is equal to, let's take a linked list of node. Okay, so you get that. So we have a queue. Then what we do is we actually say queue.enqueue and queue.add, and we add the value of root. The next thing, since we want to actually print them in different levels, so we'll actually have a null queued also. So every null will basically signify that we are going to the next level. So queue.add, and we are enqueuing a null. Okay, so we have a queue which has these things. So then we'll actually go in a while loop, while queue.size is not equal to 0, which means that while queue is not equal to null, what we are going to do is we will say node is equal to queue.remove. So we remove the value. Next, what we'll do is we'll check if this is not null. So we'll check if node is not equal to null, which means that we are still inside the at the same level. What we are going to do is, so we are going to print node.data, and we'll just put a comma or something. Okay, next what we will do is if node.left is not equal to null, then we will say queue.enqueue dot add, and we'll add node.left, and we'll do the same for the node.right. And I think we had done the same thing in the binary tree, so I'm not explaining it too much over here. It's just basically just a simple level order traversal. Else, what we are going to do is we are going to print a line. Since we have reached a new level, so we print a new line, and then we check over here if queue dot size is equal to 0, which means that if the queue is empty at this point of time, we break out of the loop. Otherwise, we'll say queue.enqueue dot add, and we will add a null, right? Because this signifies that there's a new level. So the new level will start from this point. At this point of time, I think like everything is good. I think everything should be good. We'll just print a new line. Yeah, that should do our level order traversal. Okay, so let's go to the main and let's add some values to this binary search tree. We'll say bst vst is equal to new bst, and then we'll say bst.insert, and we'll insert the root first, which is 8, and we'll basically insert this. So we'll insert 8, 3 and 10, and then 1, 6, 14, and 4, 7, and 13. So we'll say 8, and then we'll insert 3, and then 10, and then 1, and then 6, then 14, and then 4, and then 7, and then 13. So I'll add the values now. So it is 3, and then it is 10, and then this would be 1, and then this would be 6, and then this would be 14, and this will be 4, and then this will be 7, and this will be 13. Okay, so that is good. And then we'll say bst dot level order, and this should print the level order for us. Let's just run it. I think it should be fine. So just run this. So it's 8, 3 and 10, 1, 6, 14, 4, 7 and 13, which is actually correct. So our things are working correctly. Then we'll just do bst dot pre-order and check if the pre-order is working correctly. So we'll not do the level order, and we'll run this, and this will be 8, 3, 1. Let's check if the values are correct. So first we'll go to 8, then we'll go to 3, then we'll go to 1, then we'll backtrack, and then we'll go to 6, then we'll go to 4, then we backtrack, and then we print 7, backtrack all the way to 8, then we go to 10, and then 14, and then 13, and then we exit. So this is correct, and our pre-order is working. I think the post-order and stuff like that should work too. So this is just the basics of the insert and the level order for the BST. Let's come back for another video. Okay, thank you.